going? Testing 1, 2, 3, 4. No jokes. Okay. So I don't have any jokes for you today. I haven't been very funny lately. Funny looking. Maybe. Demoivres. Oh, there should be apostrophe there. Demoivres theorem. Okay. This is 6-5 part B. Sure. 6-5 part B. Okay. So we're just continuing with 6-5. And Demoivres theorem says that it gives you ways to take something like this, 3 minus 2i, and raise it to like the 10th power. Because if you were doing something like, if you were raising this to the 10th power, you'd have to multiply 3 minus 2i, then you'd have to square it, and the I squares disappear, and then you'd have to multiply by 3 minus 2i again, and again, and it would be take you really long time. But what Demoivres theorem does, it takes those multiplication and division formulas, and it kind of makes a theorem out of them, okay? And so this is what it says. These glasses are really dirty, it's hard to see out of them. So if z equals r cosine theta plus I sine theta, okay, and n is a positive integer, and n is a positive integer, that says positive integer, then z raised to the nth power is equal to r to the nth power times the cosine of n times theta plus I sine of n times theta. Okay? So, that's it. So what does that mean? So yes, ma'am.
Could you just change the color of the
I would be happy to. What color do you want? You want black?
Yeah.
Yellow. How about yellow?
No, not yellow.
Okay. So what this means, if I want to take some complex number like this and raise it to the 10th power, all I do is I take the angle theta that it makes with the x-axis, multiply that by n and take the cosine of it, and then take the angle here, multiply that by n, and take the sine of it, and then I just raise the magnitude or the modulus to that power, okay? And that would give me what that thing was if I raise it to the 10th power. For instance, I got to pause here for a second because I need to take a break. Moving on. So this is how you do Demoivres theorem. Find, is that better, Anna? Find 1 plus root of 3i raised to the 12th power. Okay? So you go, oh my gosh, I can't raise this to the 12th power. That'd be like a pain in the neck, right? And so you have this really cool thing called Demoivres theorem that lets you find that without having to do a whole lot of work. I mean, you have to do some work, but not a whole lot of work. So the first thing you do is find r. That's pretty easy to do. R is equal to the square root of, and this one works out really nice, but they don't always, root of 3 squared. So that comes out to be 1 plus 3, which is 4. Oh, that comes out to be a nice even 2, right? So this one, did everyone see why that comes out to be 2? Yeah, that's easy, okay? Then I want to find theta, okay? And so I'm going to take the, so I know that the tangent of theta is equal to root of 3 over 1, right? which is just root of 3, and that would be an angle in the first quadrant, so I don't have to worry about taking, moving it or anything like that. Who knows where tangent is equal to square root of 3? It's either 30 or 60. 60 degrees, okay? 60 degrees. So I'm going to call that, I leave it in degrees. You could leave it in radians if you want to be more mathematical. But it's 60 degrees. Yes, ma'am?
So wait, you don't have to subtract that from 360 then?
No, well, it's already in the first quadrant, right? So that, you only have to subtract it from, if you're trying to find, like when you take an inverse tangent, right? Well, it depends where it is. So if this were negative, if these were both negative, right? Tangent is also positive root of 3 down here, right? And so then I would have to, and if I plugged in inverse tangent, I'm going to get this positive number. So you have to kind of pay attention to where you are. Yeah, you have to think of where you are on the graph. Because if you do inverse tangent, you get a positive number, you're going to be here. If you do inverse tangent, you get a negative number, it's going to put you down here. But you might, the actual point might be over here, right? So you have to be careful of where you are, okay? So now I'm just going to use Demoivres' theorem. So if this is z, we'll call this z. Z equals. So z to the 12th power is going to be 2 to the 12th power times the cosine of 12 times 60, right? Plus I sine of 12 times 60, okay? And I guess like that, right? Another parentheses I need. And so that 2 to the 12th power, that's not a horrible number. I believe if you plug that into your calculator, you'd get 4,096, okay? And this is the same as the cosine of 720, right? And I sine of 720, which is a nice number because 720 is a multiple of 360, right? So what is cosine when you're right here on your unit circle?
2
Right, yeah. What is the cosine of 1, right? And what's the sine of 720? 0, okay, plus 0i, okay? And so if you multiply these together, you would just get positive 4,096. That's it, okay? Isn't that cool?
Yeah.
So if you wanted to do this the long way, you'd have to take 1 plus root of 3 times 1 plus root of 3. Multiply that together, you get 1 plus 2 root of 3 plus 3, and then you'd have to take that answer and multiply it by 1 plus root of 3 again.
It's root of 3
right?
I.
And yeah, root of 3, I, okay? And you'd have to keep going and keep going and keep going 12 times, right? You don't want to do that. So that's where Demoivres' theorem is really cool, because you could do that. Okay, so let's do one. So they don't all come out perfect like that, right? So you might have one like where you'd have to find a weird angle, okay? And you might have a weirder modulus than 2, but it still comes out. They still usually they come out okay. It's not horrible. So do you get that? Yes? No? Yes, sir.
So R is the equivalent to a magnitude, correct?
R is equivalent to the magnitude. Yes. Yes.
So you
Yes.
could
Like
have, so you could have done sine of -1 and cosine of -1.
don't confuse me. Okay. Let's move on. I'm not sure. Did I unpause me?
I don't think so.
No, I did. I'm still going. All right. Let's get a new. New piece of paper. So this this is where it gets a little bit more confusing for people, where I go the other direction. Complex roots. Okay? Complex roots. So, so this is, there are, so first of all, there are n complex nth roots. There are n complex nth roots of a complex number. Okay? What does that mean? Complex number. That means if you are taking the cube root of a complex number, you're going to get 3 answers. Okay? If you're taking the 4th root of a complex number, you're going to have 4 answers. If you're taking the square root of a complex number, you're going to have how many answers? 2 answers, and so on and so forth. Okay? So, and here's the formula. Okay? If, and the formula is really, people get really confused by the formula. But, well, first of all, if z is equal to r times cosine theta plus I sine theta, then the nth root of z, like this, okay, is equal to the nth root of r, the nth roots of z, I guess there's more than one, the nth root of r times the cosine of theta plus 2 pi k divided by n plus I sine of theta plus 2 pi k divided by n, okay, where k equals 0, 1, 2, 3, dot, 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 n minus 1. Okay? So what that means, just so you know what that means, is when you're using this formula, first you plug in 0, then you plug in 1. So if you were looking for the 4th roots, you would stop at 3. Okay? And you would have 0, 1, 2, you'd have 1, 2, 3, 4 roots. Okay? Yeah, if you were looking for the cube roots, you'd plug in the numbers 0, 1, and 2 into this formula. You'd plug in, okay? And so on and so forth. We're going to do an example. Yeah, but it's easy to find the next one. Once you find the first one, it's easy to find the next. Okay? I'll do a couple examples and show you. Okay? So, you know, it's easier to square something than the cube root. And all this is doing really is taking that Demoivres theorem, and it's doing it in reverse. Okay? And so instead of squaring something, you're square rooting it, but you have more than one root. Okay? So find the 4th roots. Find the 4. I like my other glasses better. Find the 4 complex roots of 16. And you go, wait a minute, there's only one 4th root of 16, right? And that's 2, right? But there's actually 4 of them, and 2 of them, and 2 of them are complex. Okay? Who knows what the other 2 are? What's a 4th root of 16? 2, right? Because 2 times 2 times 2 times 2 will give you 16. And then the other one is negative 2. There's negative 2. So those are the 2 real ones. You don't have to worry about how many real and how many complex they're going to be. But those will fall out using this formula. Okay? So first of all, what I would do, oops, I wouldn't do that. I would erase that stray mark. How do you do that? There we go. So I would first of all draw yourself a little picture. Okay, where is 16 on this scale?
To the right.
It'd be over here to the right at 16. Okay, so then I know that theta. I know the magnitude r. What's r equal to? So r is equal to 16 because it's just out this way 16 units, right? Or I could do, because it's like 16 plus 0i, right? So I could do 16 squared plus 0 squared, take the square root of it. Or I could just know that since I'm on the x-axis, right, then I'm at 16. So r is 16. So first of all, you're going to take the fourth root of 16, which comes out to be a nice even 2. The answer is always 2, by the way. No, it's not. But if you're just guessing,
Why not?
sometimes it's going to be 2. So anyway, then you got to find theta, okay? So what's theta in this case? If I'm right here, what's theta? 0, right? 0? So let me show you how this formula works. So the first root is just going to be 2. So we'll call it z, the nth root of z sub 0. Okay, for the 0th root. Okay, the nth root of z sub 0. That means I'm going to plug in. Oh, I can't see it. 0 into that. I'm going to plug in 0 into that formula. So using this formula, the nth root of r is 2, right, times the cosine of theta plus 2 pi k, but k starts at 0. So what's 2 pi times 0?
0.
And what's 0 plus 0?
0.
And n in this case is going to be 4, right? So I'm going to take the cosine of 0 divided by 4. That's not a 0, that's a theta. Sorry about that. So I'm going to take the cosine of 0 and divide that by 4. And then plus I sine of 0 divided by 4. And what's the cosine of 0? What?
Is it cosine of 0 divided by 4, or is it cosine of 0 divided by 4?
Cosine of 0.
That sounds the same.
It's cosine of 0 divided by 4, not the cosine of
So
0.
the n is under the cosine as well.
No, it's not. The n is not under the cosine.
Well, then how could cosine be?
Right? It's cosine of 0 divided by 4.
Okay.
Okay? And sine of 0 divided by 4. Yes?
So you take the cosine of 0 and then divide that by 4?
No. You take the cosine of 0 divided by 4.
Cosine of 0 divided by 4 is 0.
So
cosine
the
is 0, so it should
0 divided by 4 is 0, right? So you're going to take the cosine of 0. You'll see in the next one. Okay?
Then you divide it by 4.
What's the cosine of 0? 1 plus, what's the sine of 0?
0.
So it's 1 plus I sine of 0, which is also 0, right? And you get that the answer is 2. So there's your first complex root is 2. What?
We should do this 4 times.
Yeah, but it's really easy. Okay, I'll show you the trick in a second.
That's
Okay.
Yeah.
So the second time, once you got the first one, Olivia, the next 4 are easy. Okay? So 2. So I'm just going to plug into the formula, but then I'm going to show you the easy way to do it. Okay? It's going to be 0, because theta is 0, plus 2 pi times k, which in this case is 1, right? That divided by 4.
How did, how did you get 1?
2, what?
Would that be 2 pi then?
Yes.
If it's times 1.
Oh, 2 pi, sorry. You're right. Do you understand what I did? 2 pi times 1 plus I sine of 0 plus 2 pi times 1. That divided by 4. Okay? and this becomes the cosine of 2 times the cosine of pi over 2, right? Plus I sine of pi over 2. What's the cosine of pi over 2? 0, okay? So you get 2 times 0 plus I sine of pi over 2 is 1i, right? 1i, or I times 1, which comes out to be 2i. There's your next complex root.
It's 2, -2, 2i, -2i.
That's what it's going to be in this case. But it doesn't always come out as neat as that. Okay? Now, okay, so let me just do the next one. The next one is going to be 2 times the cosine 2 pi times cosine of 0 plus, you're going to plug in 2 in here, right, into the formula. So it's going to be 2 pi times 2, which is 0 plus 4 pi divided by 2, plus I sine,
It's 4 on the bottom.
oh, divided by 4, I'm sorry. Plus I sine of 0 plus 4 pi divided by 4, right? Which gives you what? Which cosine of 4 pi is the same as cosine of, or 4 pi divided by pi, which gives you cosine of pi, and so you get 2 times the cosine of pi plus I sine of pi. Sine of pi is 0, right? So cosine of pi is? What's the cosine of pi? -1. So you get 2 times, and this is 0, right? So you get -2. There's your next root. Okay? The next root is 2 times the cosine of 0 plus how many pi? Plug in 3. 6 pi divided by 4. Right? You understand where I'm going with that? Okay? Plus I sine of 6 pi divided by 4. Right? 6 pi divided by 4, which is 2 times cosine of 3 pi over 2. Cosine of 3 pi over 2 plus I sine of 3 pi over 2. This is 0, right? This is -1, right? So you get -2i when you're done with it. Follow that? Okay? So, what?
Will it always follow the pattern of just the number and then it's negative?
No. It won't, because sometimes you're finding, so here's your roots, all right? If you were to graph these, now here I just want to show you, okay? Here's my original number, 16i. It's not time to go yet. Don't pack up. I got a whole nother problem to do, okay? What time do we get out? Okay, I got to go fast then. Okay? My original number was plain old 16, not 69. Okay? So here's one root, which is out here at 2. Here's another root, which is over here at 2i, right? Here's another root, which is at -2. And here's another root, which is at -2i. These make like petals of a pretty flower, okay? If I were going to graph them, okay, they might look like this, where my original is out here. But notice that they are all how far apart? They're all 90 degrees apart. So listen up, okay, because this is where it's important. Each one, if I have 4 roots, you find the original root, you use the same magnitude, and then you just add 90 degrees to it. You use the same R value, okay? If there's 5 roots, you find the original angle, and then you add 1/5 of 360 to it. If there's 3 roots, you take the original angle, and then you add 360 divided by 3, which is 120 degrees. Because that's what the formula says, but it's hard to know. So, yeah, I'm going to do one that doesn't come out as perfect as that, okay? So real quick, I don't know if it's real quick, but so find the complex cube roots of 4 root of 3 minus 4i. Okay? So first thing you're going to do is find r. Okay? So r is equal to the square root of 4 root of 3 squared minus or plus 4 squared. Okay? If you do this on your calculator, that's 3 times 16, 48. And 16 makes 64. What's the square root of 64? 8. So the cube root of 8, right, is 2. See, I told you the answer is always 2. Okay? It's not, but in this case it is. Okay? So sometimes it'll be like the cube root of something. Sam, you're not paying attention anymore. Gotta focus, okay? This is going to be on your test. This is going to be on your homework. This is, and it's not that hard, but if you're tuning out right now, you're not going to get it. So z, the nth root of z sub 0, okay, is going to be 2. First you have to find theta, okay? So the tangent of theta is equal to negative 4 over 4 root of 3, which is equal to negative 1 over root of 3, and so that means that tangent of theta, or if I took the inverse tangent of this, I would get out negative 30 degrees, okay? Which means that theta, since I'm in this quadrant, is what? What's that angle right there? 330 degrees. So it's going to be 2 times 330, or excuse me, it's going to be 2 times the cosine, okay? First root, cosine of 330 divided by 3, since I'm finding the cube root. That's the first one. That's when k equals 0. The next one is going to be plus I sine. What's 330 divided by 3? 110. Okay? Now, all I have to do is my second root, or my one that's the nth root of z sub 1, right, is going to be 2 out in front, and I'm going to take 110, and I'm going to add 1/3 of 360 degrees to it. What's 1/3 of 360 degrees? 120. So I'm going to add 120 to it, so I'm going to get out 230 degrees, cosine at 230. Okay? And then I'm going to get plus I sine of 230. Okay? And
How
so
did you get 230?
it's 110 plus 360 divided by 3. Okay? So, there's a lot of homework on the website. Do as much as you can. We'll talk about it some tomorrow. Okay?
Oh, yeah, that's the first one.
Short periods.
So when it asks us graphically, we can just do the.
You're going to do 2 assignments.